Okay, so it should be recording now. So yeah, welcome everyone. This is Kitchener-Waterloo Video Tech Meetup in Kitchener-Waterloo, Canada. I'd like to welcome this month's speaker, Werner Robitza. Hope that's good enough of a pronunciation. He's the CEO of AVEQ. He's a QoE researcher, and he's also a contributor of the Video Quality Experts Group. And he's joining us from Vienna, and he's going to be telling us a bit about the Video Quality Experts Group. So go ahead.
Yeah. Thanks, Christopher. Thanks for having me. Thanks for the invitation. So yeah, it's a little bit late here. We have a winter storm in Vienna, but no snow, unfortunately. I think you're more blessed with that in Canada. Anyway, I wanted to introduce you to the Video Quality Experts Group, or VQEG short. Yeah, me personally, like Christopher said, I'm a founder of my own company. We do video quality measurement tools, but I used to be in academia, so I used to do a lot of research in subjective video quality. So basically getting people into a laboratory, having them rate hundreds of clips, then get to bring together the ratings and then develop video quality models based on that data. And I think I learned a lot about video quality from attending Video Quality Experts Group meetings, and also from reading the documents that they created. And so I think, it would be nice for people to know more about VQEG, and hopefully you can become a contributor at some point too. Or maybe you will find some material that's interesting for you. So a brief history of VQEG. I think it's now 25 years old. And it's basically, it started as a meeting between a couple of experts in video quality, and they got together and said, hey, let's create a new forum to discuss video quality assessment technology. At the time, everyone was still very closely related to ITU-T and ITU-R. So ITU is the International Telecommunication Union, for those who don't know, so a large standardization forum, but also a very rigorous one. And to be able to discuss more and to be able to give input to ITU, VQEG was founded, and they still have a very close relationship in the sense of providing contributions to ITU so that whatever output is generated from VQEG can eventually become a standard, like a real international standard from ITU. And so there are 3 working groups that are very important. And I guess most standards that you know or you will come across that relate to video quality, they've been made by one of these groups. And so historically, VQEG has focused on subjective tests and creating video quality models. So actually creating the whole test plan, how to develop and validate a video quality metric or model. And how do you define the test methodology to even get your subjective ratings to later develop good models? And then how do you assess the performance of model candidates so you know which one is the best? And all those approaches have been historically standardized by ITU-R and ITU-T, creating those ITU recommendations that we know for subjective testing and also for some video quality models. So we've had a couple of nice meetings in the last few years. Here's a few pictures. Unfortunately, there's between 2020 and 2022, something happened. I guess you know what it was. And so we had a couple of online meetings in between. I have to say, those are not as nice as meeting those people in person. As you can see, it's a relatively small group of people. So once you've been at one of these meetings, you will probably know everybody. And so it's very nice to meet those people again. So we've been having biannual meetings mostly. Now they're starting to be in person again. Let's see when the next one will be, I think in May or June. VQEG is organized very simply. There's a board composed of Kjell Brunström from Sweden and Margaret Pinson from the US. And then there are different working groups, each have their own chairs. And yeah, as I mentioned, we get together twice a year, mostly in person, now sometimes online. And the next meeting dates should be announced soon. I think we still don't have the hosts, but it's going to be sometime in May or June. Here's a list of chairs. I won't go through that, but I will share the slides with you so you can have a look. Maybe you know somebody. And it's just nice to have an overview of the different groups. But I'm going to get into that anyway. So what's nice about VQEG? This is a very personal slide, but for me personally, I think it's a really nice forum to attend. First of all, it's free to join, so there are no membership fees. As the founder of a small company that's bootstrapped, I think that's also very nice. You don't have to pay thousands of dollars just to be able to attend. So that's good. And then there are no strict or complicated rules, right? With, let's say, with an ITU-T or ITU-R, reaching consensus is sometimes very hard and a very lengthy process. So sometimes you might, like, people discuss about one sentence for an hour. And this is not the case within VQEG, right? So you can easily reach consensus here. It's also very easily or very simply organized, right? There's no strong hierarchy. There's just chairs and co-chairs for different projects, and anybody can propose or contribute to those projects, right? So there's no entry barrier, basically. And those meetings are highly interactive. So I would say, like, there are presentations, of course, but then there's also discussion time, and there's a really strong focus on discussions. So if you have an idea, if you have a question, people will devote time to really answer that question or to discuss, take their time to discuss, which I think is important. Also, it's not a commercial venue, so there are no sales talks. There's no commercial advertising, which is also nice. And in terms of attendees, it's a good mixture between academia and industry. So we have folks from, we've had people attend from YouTube, from Google, from Netflix, from Apple. So from the big tech companies, but also smaller bootstrap companies and smaller startups maybe, but also many different universities. And so, as you can imagine, this creates a nice forum for discussing new ideas, but also thinking about how certain ideas could work in practice, or what things that don't really work in practice. So that's a thing that happened to me personally, creating coming up with ideas for video quality models that in practice would never work, because you would never be able to get that kind of data to perform this kind of analysis, which all sounds nice from an academic perspective, but in practice there are always limitations. And so being able to discuss that before you go ahead and do your project, I think that's very good to have. So I want to share with you the general topics that VQEG is about, and also some of the resources that we've published, which I think could be very helpful for you. So the main topics are, of course, research on video QE in all kinds of fields. And then there's the video quality model development. So historically, VQEG has published or helped create different types of video quality models. You may be familiar with the different types of video quality models, like hybrid models or bitstream models or no reference models, depending on which kind of information they use as input. And VQEG has been defining the scope of the model and coming up with the test plan, and bringing together the contributors, and then actually recommending models to be standardized by ITU-T. So this is this input to standardization forums here. Basically, VQEG collecting data and then going to ITU and saying, these are the best models that we have for this type of input. Consider this for standardization. And of course, when you are developing a model, you will do a lot of subjective tests, and you will collect databases of videos and ratings to develop and validate those models. And these have been saved, of course, and they've been published and are available within VQEG for sharing. Also, there's a lot of software tools that we are using. I will show you more about that later. And then there are new application areas, which I think is like a very open-ended field. So there's a lot of discussion about things like multimedia or 3D TV back when it was still considered the new thing. Now nobody's talking about it anymore. There's gaming, there's VR, XR. So whatever's on the horizon and whatever has to do with video in some way or another is probably going to be discussed here as well. So here's a historical approach that VQEG has taken to develop video quality models. So usually there's this idea of wanting to develop a model, and you come up with a test plan, right? You define the scope and the terms of reference in which the model should work. So you have to define your inputs and outputs. So you're going to say, for example, we need a full reference type video quality model that works on short video sequences. Maybe something like VMAF. At the time, of course, VMAF didn't exist. We would be talking about videos with a 320 by 240 resolution, but the idea is the same. And then you come up with the rules for model submission and validation, because you want to be sure in advance when you're contributing your model candidate how it's going to be evaluated. And then there's going to be a call for participation, both to industry and academia, to bring in their model candidates. And also, the training databases, they will be developed jointly, mostly. So you make a test plan, right? You think about how many different subjective databases do I need, which type of video content do I need, etc. And then you share that training data among those who want to contribute their model. And then there's usually a model training period where different proponents get the training data, and then they either collaborate or it's done in the form of a competition where everybody has time to develop their model, and then they can submit it. And at the end, you will see who's going to be the best. Then there's a validation phase, because to really make sure that a model works well, it has to be tested on previously unseen data. And this is what happens here, right? So the group will usually develop new databases with new content, and then new tests are being conducted, and the models are going to be validated. And finally, all this data is being analyzed statistically according to criteria that have been set in advance, right? So there's no changing of the goalpost after the fact, which is very important. And really, this has worked quite well for the past 10 or 15 years, I would say. But it has changed. So now I think model development is more iterative or collaborative, or actually done within ITUT itself, for different reasons that I will maybe get into later. Some of the previous projects you may know, you may have heard about some of these ITUT recommendations. As you can see there, some of them are quite old, but I think from a technological point of view, those are still quite interesting, because many of the techniques that we use for video quality modeling today, they are not new, right? I mean, they've been there before, maybe they're refined now, but when you talk about signal-based analysis, comparing video sequences, this has all been done before, right? It's just the resolution that keeps increasing, or the type of application area that's changing. So the most recent project that VQEG has done is a joint project with ITUT. It's called Peanuts Phase 2. So this led to the creation of different types of video quality models that work on UHD or 4K content with up to 60 frames per second and different codecs. And I think that has been the biggest model development project ever done. And there's a nice paper summarizing everything that has been published, which I really encourage you to read. Some of these models work quite well. They are different types of models, so they can be used in different application areas. Some of them work as well, if not better, than VMAF in some contexts, but they're not as well known because there's also no company directly publishing them, right? Which I think is one of the downsides here. Some of these models are quite obscure, although there's really good tech in there. And so this is also one of the big questions nowadays. What's going to happen in the future? Now, basically, VMAF is the de facto standard, although it's not a like ITU standard or anything. But this raises the question where VQEG will fit in the next few years. Like, do we need to develop new model types, new models, or should we rather collaborate and iteratively improve existing technology, right? So, but yeah, historically, this has been how this is how it has been done, and sometimes no models could be standardized due to low performance. And I think this is also important to mention. At VQEG, we wanted to make sure that if a model was developed and it didn't meet performance criteria that were set in advance, it wouldn't become standardized. And this is mostly the case with no reference pixel-based models. So those that don't have access to a source video and where you only look at a video and you have to tell whether it's good or bad. And those usually don't work well. And we are now investigating why that is the case or what could be done to improve no reference models. But we're still at a point where those are not reliable enough to become standardized. Yeah. And so as a byproduct of these efforts, we've created a video library. So it's called the CDVL, or Consumer Digital Video Library. And it's available online. You can find it also linked from the VQEG website. I should have put in the domain there, but it's a link. I will send you the slides. It's cdvl.org. Yeah, you can register and you can search for video content. And this is basically the content that has been used to train most of these existing models, right? So if you're looking for any data set, you will probably find it there. Then we also have a repository for software tools. This is also completely open. It's on GitHub. Tools in various categories like quality analysis, encoding, streaming, subjective test software, and also other helper tools. I think the latest, these last two categories are mostly the most interesting. Like when you want to set up a subjective test, like you need a software to present videos, you need a software to collect ratings. What if you want to do it through crowdsourcing? So there's all kinds of tools in there. So go ahead and check it out. If you know a tool that is not in there, please do create a pull request and add this information. It's really easy to do, and it will help others discover it. There's also a bit of dissemination. So reports from previous test and model development activities are on the VQEG website. And although they might be 10 or 15 years old, I think it's really helpful to read through some of those in case you want to create a new subjective test, just to understand what actually needs to be done to do this properly. For me as a student, when I got into video quality, this was really helpful, like just reading through those documents. And I think these days, it's not documented as much anymore. And so, yeah, this is a nice record of how to properly do a video quality test and also develop a model. And then there's also an ACM publication with recent updates. So there's a latest issue from those SIG multimedia records, which actually contains a detailed summary of the last VQEG meeting. So in case you're interested in the like a list of individual presentations, please do check that out. Yeah, and so now for a brief overview of the current activities. You can find those also, of course, described on the VQEG website, but here's just a high-level overview for you to see whether there's something interesting that you could maybe contribute to, or that you just want to join some of those meetings, right? So there's the Statistical Analysis Methods Group, or SAM. It's all about how to analyze data from subjective tests. So with the problem statement being, you have a test that you want to do, how should you be collecting the ratings? How should you be analyzing the ratings? There's a nice method that was developed based on a Netflix tool called Surreal, which helps you recover the real ratings from noisy subjective data. So imagine you have a subjective test where you ask 25 people to give their ratings about the ratings on, I don't know, 100 video sequences, for sure there are going to be people who always give a negative score, or some people who will just randomly score the video quality. And maybe there are some video sequences that have errors or a large span of ratings. And so this tool will modify the data in such a way that the score that you get at the end, like the mean opinion score or the average score for a video, more closely represents the ground truth score. And there are some plots that I included here, which could be used to visualize the ratings for a data set. For example, here you can see something is off there, and this is an indication of corruption in the data set. So those are just some helper plots that have been used to analyze the data. We've also recently updated ITU recommendations BT 500 and recommendation P910 and 913. I think these are the go-to recommendations if you want to do a subjective test. And basically at VQEG, we're making sure that these are up to date. We're getting rid of the old cruft. I think one of those recommendations still mentions CRT displays and how to do tests on them. And so we're trying to keep them up to date and remove anything that's not needed anymore. So this is one of those activities. We're actually right in the middle of updating ITU-T P910 and P913, trying to harmonize them, bring them together, where we could also use some help from the outside, or some people who want to read through that. I think that would be nice. Also, there have been some interesting historical activities all about how to obtain the most valid and reliable ratings from humans when you ask them to rate a video. For example, in 2011, or actually the question is way older, right? Which type of rating scale do you use for people to assess the quality of one video sequence? Do you use 5 points, 5 discrete points, or do you use a continuous scale, or do you use a 100-point scale? And we were never sure which one to use. And then people from VQEG got together and said, okay, let's do the test to find out. And so this is the paper from 2011 where they compared all kinds of rating scales, and it turns out that some of them are basically not necessary. People tend to cluster their ratings at discrete points, even when they're asked to provide ratings on a continuous scale. So maybe just use a 5-point scale and discrete scale. And it's easy enough for people. It's easy enough to analyze. You don't have to worry about all the other ones. So that's, I think, very interesting, or at least it was very interesting for me personally. And then there are other papers that are also very interesting. So does the test environment itself have an impact on the video quality? Like whether it's done in one lab in one country or another. And then maybe the question of, does it make a difference whether you always show the same sequence to people or not? Like, what if you want to show 100 different videos with different distortions? Can you use the same Big Buck Bunny clip for 20 of them? And are people still going to be watching that when they rate video quality? Like, are they going to be bored or not? And so there are interesting experiment designs that you could use to make it a little bit more interesting for people to rate video quality using non-repeated scenes or similar scenes where the scenes are different, but the distortion is the same. And so you get a nice experiment design that you can still analyze with respect to video quality. Then there's the no reference metrics group. As the name says, it's about designing a no reference pixel-based metric, so a metric that will analyze video quality without having access to the source. And what we've done is we've collected various resources for no reference metrics. I mean, people have tried this before, but as I mentioned before, none of those are really performant enough to become standardized. And so what we're doing now is, and this activity is heavily driven by Margaret Pinson, collecting all kinds of video data sets which are interesting for no reference metrics. So this is not just your typical video on demand type video sequence, but this contains user-generated content, or also security-related content like footage from security cameras. where it's even harder to assess video quality properly because you have really crappy quality from the camera itself, and this is not the encoder at fault here. So what does the metric do with that? There's also an open framework containing lots of MATLAB implementations for various metrics that could be used, or various indicators that could be used for one single no reference metric. And there's a nice journal paper that was recently published which explains in detail why some of those metrics are not accurate enough. And you can see here's a correlation plot between different indicators and different data sets. And if you can read a correlation plot, you will notice that sometimes there's no correlation at all. Sometimes it really doesn't work at all. And some of those metrics are better than others, but we still don't understand why. So, for example, some of those indicators might be blurriness or blockiness or lightness or colorfulness, etc. So how do you bring those together to create a no reference metric that works well? There are also other activities like video complexity. So the question is, how do you determine the complexity of a video before you encode it? There have been two indicators in use for years now called spatial and temporal information in ITU-T P910. We've updated that to make sure it works for HDR, but this is not enough. We also want to find new metrics to be able for you to answer, or to be able to answer the question, if I have a video and I want to encode it with a certain quality target, which bitrate do I need so it doesn't look bad? Which is only really possible. I mean, you can just encode it and look at the results, but then you would have to do, I don't know, 100 encodes and see which one works best. Ideally, you would have a metric that could tell you in advance, which is especially useful for a live scenario where you don't know what's coming in and you have to make your encoding decisions on demand. And now we are trying to do this with a new motion search framework that has been published by Meta, which would allow us to more quickly make decisions about how complex the video is without actually encoding it. There's also a video complexity analyzer from the University of Klagenfurt, which we're looking into. So yeah, this is a current activity. And another is finding a standard for embedding video quality metadata in bit streams or in containers. Because when you do video quality research or when you do encoding, it would be nice to remember what the video quality was when you encoded a sequence. So when you get it again and you maybe need to re-encode it, you can make more informed decisions about possible degradations in that second encoding stage. Or when you're working with a lot of user-generating content, you have complicated pipelines. These are all questions that come up in larger companies dealing with lots of video, and so we've come up with some way to specify video quality related data inside a container or bitstream, and now we're trying to get that actually into MPEG and AOM to make it work in practice, which is also hard, but we're trying. There is also a group on computer-generated imagery, so everything related with gaming or anything that's rendered on a computer. So here, basically, the idea is to create models that specifically work for gaming content because it's so different from classical video content. And this is closely aligned with an ITU-T work item called P.EVQCG, where they want to develop a model for gaming QE. And previously, leading up to that, there have been various ITU-T recommendations standardized, for example, how to even do subjective tests for gaming quality, because there's an interactivity component in there, which it's really not the same compared to just watching a Netflix video, because people, when they do the test and they play a game, they will actually change the thing that they are rating. And so how do you do these tests while developing a model, which I think is a very complicated question and which P.EVQCG is covering right now. There's also the joint effort group Originally, they wanted to develop a hybrid quality model, but that never worked out, and they actually shifted to different, more research-oriented questions. For example, how do you model the behavior of a single person during a subjective test? Can you predict individual quality ratings using neural networks? Or how do you model the disagreement between different video quality metrics? So imagine you have a sequence and you run different metrics on it, and they all kind of disagree, or you have rank order differences when you run different metrics on a data set. So what do you do with that? How do you quantify that? Which is the best metric if they all disagree? These are questions that JAG is dealing with. And you can see, like, here's a block diagram of a network trying to predict an individual quality rating. So really interesting recent research there. Then we have the IGVQM group, which is a very small group. We created a working document that is basically a guide of how to properly use a video quality metric, because there are so many out there. And we wanted to just collect all metrics and open source solutions, highlight the differences between those metrics, and also, think about how do we deal with basically image-based metrics like PSNR or SSIM that are not necessarily perceptually linear. How do you map between those, etc. So this is an interesting document that you can also read through. We're not quite sure what we want to do with it, but I think we would like to disseminate it at some point to a broader audience. There's also quality analysis for computer vision applications. So all about, automatically determining information from video. I won't go into the details here because we're quite short on time now. But it's about, recognition tasks and like, how does a computer how can a computer understand video content with respect to the quality of the video? So this is the Wachovia group. There's a 5G related group. So here the idea is to understand special use cases for video in 5G, for industrial scenarios, like where latency is important, where mobility comes into play. What are the KPIs that have an effect on video quality or picture quality even, or on synchrony? And there's an interesting recent technical report that lists all those requirements and performance features from a network perspective that are related to video QoE. And there's the immersive media group, which is dealing with 360-degree video, virtual augmented reality, planoptic video, or other types of three-dimensional content, which also has been very hard to assess. I mean, it's very different, it's very interactive. The big question, how do you properly or how you collect ratings in such a way that they're valid, like that you measure the thing that you want to measure when you ask people to rate the quality of something that they've never experienced before. Those are the type of questions covered by the immersive media group. There's a group related to health applications. So here they assemble databases for medical image and video quality. So basically the idea is this is a really critical application. You cannot compromise on image quality, like introducing artifacts. How much should you compress a video or an image before it becomes too degraded? What about telemedicine or telehealth applications? What are the requirements for QoE there? So it's a really, really interesting cross-section between different sectors here, medical and industrial. Also some recent presentations that have been given at the last meeting, so feel free to check that out if you're interested in that. And lastly, there's the emerging technologies group, which is new and covering everything that is new, like AI-based technologies for super resolution or AI-based video compression, greening of streaming, so anything that has to do with saving energy, but also making sure that it's still good in terms of quality, which I think we'll hear more about in the coming years. They're also talking about blockchain and also liaising with other standards activities like 3GPP, streaming video technology, etc. Yeah, so basically lots of different topics. Feel free to join or attend VQEG. It's free to attend. Please contribute. I think this could really lead to new standards being developed, nice collaboration between academia and industry. I think we're all about reproducible research and making everything openly available, like databases and software. And if you have questions that you need answered, or if you want to discuss something about new technology, I think this is the place to go, because there's certainly a group that covers your topic. Have a look at the projects page. You can subscribe to the mailing lists, although I will say they're a bit quiet. I think the best way to contribute is really to join one of the regular online meetings. So there's a list of meetings on the website. If anything sounds interesting to you, just join. We've had people come in, give a presentation, getting feedback. There's really no barrier to entry here. Yeah, and let's see when the next meeting will be, sometime in May or June. Would be happy to see you there. So thank you.
That was a great sort of overview of the VQEG group. I'll open it up to the floor now, and you can use the Google raise hand if anyone has any questions. I had a question about with the CGI group. Are they looking to like work with 3D engines to like degrade quality like in a graceful manner type of thing? Is that the idea but behind that group?
So the way I understand it is we're mostly interested in network quality and encoder quality. So both of these factors, right? So trying out different settings for encoders and see how that impacts subjective video quality. Like, can you introduce a little bit more latency to squeeze out a little bit more quality if you're using like a GPU encoder? So that kind of thing, right? We're not talking about this.
It's not rendering. It's more like cloud gaming related, where you want to kind of take the latency into account.
Exactly. Yeah. So we're taking the games as is, and then understanding like how should you encode it, and also what impact does the network have? Like how much of jitter can you tolerate before it becomes unplayable? Things like that. Yeah.
Anyone else? Wentao?
Hi, thanks for your nice presentation. So yeah, it's a really great introduction to the VQEG. Yeah, I have. So I think I heard you mentioned that VQEG normally reaches agreement very quickly. So yeah, I probably I missed some part of your presentation due to some jobs. Yeah, but I would like if you have already talked about that, I apologize, but I would like to ask how it normally works, like how people in the group reach an agreement and decide to, for example, start a project or to start to write down some document or write down some recommendations or something.
So it's really very open, right? So it's not like the chairs of each group will mandate something. So if you have an idea for like a document that should be created, if you have an idea for something that should eventually become a contribution for example, ITU, historically people have just come to the group and told them, yeah, like I want to do this document. Here's a draft. Could we please discuss this? Here's my goal. And if there's enough interest, and of course, if there's willingness from the editor to really work on the document, then there's nothing preventing that from going through, right? We've had lots of liaison statements with other standardization bodies. I've also authored some of those documents. People have always brought in ideas if you make a Google Doc and if you're planning to edit it over, I know, the span of 1 year or 2 years, I think you will certainly get input and agreement to maybe publish it or to disseminate it to other forums. Yeah.
Okay, I see. Oh, so yeah. So my understanding. So yeah. So from an answer, it's like, so there will be like a lot of discussions other than the biannual meetings, right? So,
Yes.
yeah, so offline. So okay, got it.
Yeah, we have these ad hoc meetings from the different groups happening every month or every 2 months, which are, I think, the place where most of the work happens. Yeah. But also at the meetings themselves, if they're in person, obviously this is a nice place to discuss and develop ideas. The online events are a bit harder for me personally, at least, to attend, because discussions online, as you may be aware, are not as productive as they are between a handful of interested people when they're in the same room. But we're still trying, and obviously there's still output happening. What it takes is really at least one editor who is willing to push forward the topic, and then other people who are interested in maybe doing tests, writing some analysis scripts, writing some software to do something, bringing together resources, etc. Yeah.
Okay, thank you.
Any other questions? I had another about the greening of technology. Like, is the idea? I know even at one of the talks from DMUX, the idea that going from 264 to 265 should and the hardware required, like the overall, I guess, environmental cost is seen as being less, but now that's being transitioned. The gains that you would get from having to do fewer encodes or whatnot are now being done to like tune quality, and it ends up being maybe a net negative instead of a net positive in terms. Is that like looking to make recommendations to ITU groups and then having those kind of work with governments to kind of help with that?
So, I mean, this is a very new topic for VQEG. Some of you may be aware of the Greening of Streaming initiative, which is, I think, it's another forum where lots of industry partners have actually come together and formulated the same goals. And they already have a methodology to assess the impact of different decisions when it comes to encoding or encoding infrastructure on like the complete output in terms of energy usage. What I think VQEG is mostly concerned with, and which I think is still missing from the Greening of Streaming project's perspective, is the one of the end user, and the one of quality of experience from the end user's perspective. So meaning, for example, can we come up with a test scenario where we can actually find out whether people are willing to press the green button in a video player to have less energy consumption, or how much could you degrade the quality before people would start to notice, like, can you use less bitrate? I mean, for example, YouTube has been aggressively like lowering video quality on mobile devices for some time now. And I've noticed myself, but I'm a video quality researcher. So the question is, like, at which point do normal people notice? And would they be actually willing to accept that if they knew it was being done for environmental reasons? And I guess questions like that are more from the end user's perspective are what's interesting for VQEG. Yeah.
Great. Any other questions? Okay, great. Well, thank you, Werner. This has been a great introduction into VQEG. Thank you for taking time out of your evening, and thanks for everyone for joining. And don't have a speaker lined up for next month, and it being a short month, we might skip it. But yeah, so thanks everyone. Werner, if you want to give me those slides, if you want me, I can publish them somewhere.
I just post the link in the meeting.
Okay,
chat.
awesome.
Yeah.
So yeah, thanks everyone. Have a good day, and see you later.
Thanks, Chris.
Yep.
Thanks for having me. Bye-bye.
Thank you.
Bye.
Thanks. Bye.
Thank you.
Thank you.
Thanks so much.